start off with exponential functions by doing some basic calculations involving exponential functions. Exponential functions a lot of times uses the number e. If you have 25 to the 1/2, for example, this is asking two questions. What times itself that number of times gives you that number? That is, what times itself 2 times gives you 25? Well, 2 times 2 is not 25. I'm multiplying 3 by itself 2 times. I get below 25. I try 4 if need be. I don't get 25. Oh, 5 times 5 2 times is 25. What times itself 2 times gives us 25? 5. Now raise 5 to that number. Raise 5 to the 1, and 5 to the 1 is 1. If somebody asks you what 81 to the half is, what times itself 2 times gives you, what positive number times itself 2 times gives you 81? It's 9. Raise it to the first power, you get 9. An alternate way is 1/2 power means square root. Square root of 81 is 9. And the last problem, 25 to the half. There's 25, and half as a power means square root, which is 5. Thing is, sometimes the power is not a half. Sometimes it's a third. If somebody asks you what 64 to the third is, or 2/3, it's asking two questions. What times itself that number of times gives you that number? Well, what times itself 3 times? You really don't know. You just don't say, I don't know, and you give up. You try. I multiply 1 by itself 2 times. I got below 64. Let me try 3. 3 times itself, 3 times 3 is 9, times 3 is 27. That's still too small. Sorry about that. If you try 4 by itself 3 times, 4 times 4 3 times, well, 4 times 4 is 4. Excuse me. 4 times 4 is 16. 16 times another 4, that gives you 64. What times itself 3 times gives you 64? 4. Now, square that number. That is, multiply that answer by itself 2 times. 4 times 4, or 4 squared, 16. There's absolutely nothing hard about that other than knowing the procedure. You must know what it's asking. It's asking 2 questions. What are the 2 questions that something like this asks? What times itself that number of times gives you that number? And whatever you get, here's another thing. What do you get when you multiply that number by itself that number of times? If somebody asks you what is 8 to the 2/3, you have to answer 2 questions. What times itself 3 times gives you 8? The answer is 2. 2 times 2 times 2 is 8. Now take that answer. What is that answer times itself 2 times? That is, what is 2 times 2? 4. That's what it's asking. Okay. Now, next set of problems, and there aren't too many in this section, the next set of problems you have to remember. If the bases are the same and you're multiplying, you add the exponents. You add the exponents. And I want it to be natural. Like if you have 2 cubed times 2 to the 5th. This is not 2 times 2. Because that's not 2 and that's not 2. 2 cubed means that. times 2 to the 5th. Well, that means this. 2 times 2, 5 times. Well, how many 2's are we multiplying? Well, we have 3 here and 5 there. We have 8. 1, 2, 3, 4, 5, 6, 7, 8. And by definition, the shorthand way of writing 2 times 2 8 times is 2 to the 8. You add the exponents. Anytime you forget that, if somebody asks you what is 2 or 12 to the 308 times 12 to the 211, I don't expect you to write down 12 308 times, and then write down 12 211 more times. Look at an example like this and realize, oh, I just add the exponents, and then when you come here, you keep the same base, and you say, I'm really multiplying 12 by itself 519 times. Picture 12 times 12, 308 times. There are 308 12s I just wrote. Why don't you see them? Because the sum in those dots. That's shorthand notation for writing down 12 308 times. I'm telling you how many times I wrote it down. 12 times 12 times many, many more 12s. How many times? 308 times. Times 12 to the 211. 12 times 12 many, many times. How many times? 211 times. How many 12s did I write down? Well, here I wrote down 308, and then I wrote down 211. How many did I write down altogether? 9, 1, oh, 519. This is 12 times 12 many, many times. How many times? 519 times. But there's a nicer notation than this. It's 12 raised to the number of times I wrote it down. You add the exponent. And you can forget that any time you want. Just look at a simple example. You don't multiply those exponents. So, if somebody were to ask you what 5 squared times 5 cubed is, you tell them it's 5 to the 5th. Now, if it's too complicated to multiply 5 times 5 5 times, you can leave the answer like that. But this one isn't so bad. 5 times 5 times 5 times 5 times 5. That's 25, and that's 25. You should know that 25 times 25 is 625 times 5. You should even know that. 5 times 600 is 3,000. 5 times 6 is 30 with the 2 zeros. 5 times 10 is 100. And I meant to say 5 times 20. That's a 20. And then, lastly, 5 times 5 is 25. 3125. 3125. Whatever you do, don't do 5 times 5 is 25. 25 times 5 is 125. That's not a good way. For example, if you want to do 3 to the 4th, you definitely don't want to do that. 3 times 3 is 9. Most of you know that. Great. Most of you know what 9 times 3 is. It's stuff that we memorize. It's on our times table that we memorize. 3 times 3 is 9. 9 times 3 is 27. Excellent. Then 27 times 3. Oh, let me run and get pencil and paper on my calculator. Doing it too complicated. Let's try to use it so we never leave our times table that we memorize. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. I memorized 3 times 3, and I memorized 9 times 9. I never memorized 27 times 3. Happens to be 81, but that's too complicated. So 9 times 9, 81. And if you were asked to do 3 to the 5th, which is 3 times 3, 5 times, 9 times 9 is 81. It's 81 times 3. You want to use pencil and paper now? Fine. But you didn't have to use it after 3 times 3 is 9. 9 times 3 is 27. You didn't have to use pencil and paper for 27 times 3. If you have 3, it is a 6. If you have 3, it is a 6. What's 3 to the 6? It's 3, 3, 3, 3, 3, 3. It's 9 times 9 times 9. 9 times 9 is 81 times 9. If you need, fine, you use pencil and paper now. But if you did 3 times 3 is 9, you can do that in your head, times another 9 is 27. Well, 27 times 3, you're going to run through your calculator. That's 81. That's one time you use your calculator. 81 times 3, 243, you're going to run through your calculator. And 243 times 3, which is 729, you're going to use your calculator or pencil and paper. That's 3 calculations you had to do using pencil or paper. Or you can just do 1. 9 times 9, you should know, is 81. 81 times 9, if you claim you don't know that, use pencil and paper. But just for the record, I'll show you how to do 81 times 9. You use the distributive law. You just use the distributive law. 9 times 81. This is 80. Well, 9 times 8 is 72. 9 times 80 is 72 with a 0. It's 720. Plus 9 times 1. It's 720 plus 9. It's 729. If you were asked to simplify 5 squared over 25 squared, well, this is the same as 5 over 25 all squared. And 5 over 25, well, 5 goes into 5 one time and into the bottom 5 times. It's 1 over 5 squared. 1 squared over 5 squared. Okay, why is that true? Why, if you have a squared over b squared, why do you get a over b all squared? Well, a squared means a times a, b squared means b times b. That is the same as a over b times a over b. And if you don't buy that, a times a, well, that's this, or it's a squared. Multiply the bottom, b times b is exactly this, which is exactly b squared. They are equal. And if you multiply the same thing by itself 2 times, you get a over b, in this case, squared. And, you know, if it was any power, a to the n over b to the n, you multiply a by itself n times. You multiply b by itself n times, the same number of times. That way, since they're the same number of times, you could pair them up, top to bottom, pair them up. So you have a over b times a over b n times. Oh, I'm multiplying the same thing n times. I write down the common thing that I'm multiplying by itself, namely a over b to the n. Now, I mean, this was very elementary. let's solve for x's in some problems. And if it wasn't elementary, what I mean by elementary was it was taught in our pre-algebra. It was taught in the remedial math course. Now, if somebody asks you to solve for x, and this is asking 3 times itself, how many times gives you 81? Well, I don't know. 3 times 3 is 9, times another 3 is 27, times another 3. Oh, I don't know what 27 times 3 is. Oh, 9 times 9. Oh, 81, 81. So the answer is x is 4. That is 3 to the 4th equals 81. X is 4. If you're asked 5 to the x plus 1 is 125. 5 times itself that number of times is 125. Well, get your hands dirty. 5 times 5 is 25. 25 is like a quarter. A quarter times 5 is $1.25. It's 125. That is 125 is 5 cubed. 5 to this power is equal to 5 to that power. These powers have to be the same. You can't multiply 5 times itself different number of times and get the same answer. If on the right side we're multiplying 5 by itself 3 times, and the left side we're multiplying 5 by itself x plus 1 times, it must be true that x plus 1 is 3. Some number plus 1 is 3. 2 plus 1 is 3. There's our answer. X is 2. 2 plus 1 is 3. Don't take away 1 from both sides. You have 1/3 to the negative x is 27. First thing I would do is get rid of the negative sign. If you want to get rid of the negative sign and just have power of x, if you want to get rid of the negative sign, you have to flip over the base. Done. I flipped over the base. They come in pairs. You flip over the base, you change the sign of the power. If I don't like that, remember that's 3 over 1 to the x. If I flip over the base, that's allowed. But then I better change the sign of the power. Instead of an understood plus x, I write minus x. If you flip over the base, you change the sign of the power. If you change the sign of the power, you have to flip over the base. Flip over means take reciprocal. Okay, and this is equal to 27. But 27 is 3 cubed. So 3 to some power is equal to 3 to the 3rd power. X is 3. The powers have to be equal. So, how about x plus 3 to the 4/3 power is equal to 16? I mean, it's asking one number times itself 3 times and then multiply that answer by itself 4 times gives you 16. That's a bit complicated. It was so complicated that I'm pretty sure what I said wasn't even true. You would love to get rid of that power by the x, by their x plus 3. Well, if you raise the left side to the 3/4 power, and you do the same to the right-hand side, 4/3 times 3/4 is 1. And raising something to the 1st power, you don't have to do. X plus 3 to the 1st power is just x plus 3. And the other side, what times itself 4 times gives you 16? Well, try 2. 4 times 4 is 16. So it's 2 to the third power, which is 8. Some number, when you add 3 to it, bingo, you get 8. If you really don't know that it's 5, here's that number. When I add 3, 1, 2, 3, I get 8. If I take the number and I add 3 to it, I get 8. So I took a number, I added 3. 1, 2, 3, and I get 8. Well, then that must be 7, and that, 5, x is 5. Okay, that, if you can do that, I'm not suggesting that you should, but you should know how to do that. If you can do that, then you have a complete command of what that's asking. It's asking if you start at some number, which we call x, and you add 3, you get 8. Well, then just count back. 7, 6, 5. X is 5. That is 5 plus 3 to the 4/3 power is 16. Let's make sure. Maybe we made a mistake. 5 plus 3 is 8. What times itself 3 times gives you 8? 2. Take that answer, 2, and multiply it by itself 4 times. 2 times 2 4 times is 16. Exactly what we're supposed to get. There's no doubt in my mind that x is 8. I know it is. I checked it. Suppose I tell you that 18 squared is 3x plus 1 squared. Well, what can you square? What can go in there? So when you square it, you get 18 squared. And the answer is plus or minus 18. If you square negative 18 or positive 18, you get the same thing as squaring just 18. So 3x plus 1 can equal plus or minus 18. That is 3x plus 1 can be 18, or 3x plus 1 can be negative 18. 17 plus 1 equals 18. 3x is 17. If 2 times 5 equals 10, for example, 10 divided by 2 equals 5. Always, excuse me. Okay, that's always true. If 2 times 5 equals 10, then 10 divided by 2 is 5. If A times B equals C, C divided by A is 10. 17 divided by 3 is X. That's one answer. What number, when you add 1, gives you negative 18? And we happen to be calling that number 3x. If you take 3x and you add 1, you get negative 18. Remember, zero's there. This number, negative 19. 3x is negative 19. Negative 19 over 3 equals x. Those are the two answers to this problem. You can square two numbers to get whatever 18 squared is. You can square 18, or you can square negative 18. Let's try this one. Not a big deal. The number e is some special number, just like pi is. If I told you that e to the 2x is equal to e to the 5, the bases are the same. The exponents are equal. 2x equals 5. 5 over 2 equals x. 5 over 2 equals x. Remember, x to the 0 is equal to 1, provided x is not 0. 0 to the 0 is not 1, okay? But 5 to the 0 is 1. 7 to the 0 is 1. Negative 2 to the 0 is 1. Any non-zero number raised to the 0 power is 1. So if I tell you that e to the x is 1, and e is not 0, then the power must be 0. If this number to the 0 power is 1, the x is 0. Try one more. Suppose I tell you that x to the 3/4 is 8. What you do is you raise both sides. So you want to get x alone. You want to get x to the first power. So just raise both sides to the 4/3 power. Why 4/3? Because 3/4 times 4/3 is 1. This is really x to the 1, which is 8 to the 4/3. But x to the 1 is x. That's why we raise to the 4/3 power. On the right side, what times itself 3 times gives you 8? Well, 2 times 2 3 times is 8. And then multiply that answer, namely 2, by itself 4 times. 4 times 4, 16. So a check would be 16, x is 16. X is 16 to the 3/4. Does it equal 8? Well, what times itself 4 times gives you 16? 2. 1, 2, 3, 4. 2 times itself 4 times is 16. And take that answer 2 and multiply it by itself 3 times. And we get 8, just like we should. Okay, in the next section we'll talk about graphing exponential functions.